Let's work through. Let's walk through this 2.2 homework problems, 97 through 100, dealing with position, velocity, acceleration, particle motion problems. So let's look at number 97 here. We're starting off with the position function in this form, negative 16t squared plus v sub 0t plus s sub 0. V sub 0 represents the initial velocity. S sub 0 is the initial height or position of the free falling object. And negative 16 is acceleration due to gravity, negative 16 feet per second squared. So here's our position function. And 97, the problem starts off, silver dollar is dropped from the top of a building that is 1,362 feet tall. So the dollar is being dropped from the top of the building. So we know that the moment that it's dropped, that it starts falling, it's going to start off with initial velocity of 0. And the initial height is 1362. So we can go ahead and make those substitutions and create our specific position function for this problem. S sub t is equal to negative 16t squared. V sub 0 is 0. And initial height is 1362. So here's our position function. Part A says determine the position and the velocity function. So we have our position function, which is S sub t. Velocity function is the derivative of position. So we go through power rule. Negative 16t squared becomes negative 32t. 0t is just going to be 0. And 1362 is a constant. So constant's derivative will go to 0. So our velocity is simply just negative 32t. Part B says determine the average velocity. So one thing we have to keep in mind is velocity doesn't necessarily mean that we're using the velocity function. In this case, if you're asked to find the average velocity and you're given two time intervals, two time endpoints, that means the definition of average velocity in this case is change in position over change in time. So average velocity is the rate of change of position. So we're actually going to be, essentially it's using slope. This is asking for the slope between the two positions at these time intervals. So I think the natural tendency for students is to think of it as taking the velocity at these 2 points and adding them together and dividing it by 2 and calling that average velocity. But we just have to keep in mind that the definition in this case for average velocity is change in position over change in time. So it's the slope involving the position functions. So our endpoints are at 2 and 1. So s of 2 minus s of 1, this is change in position over change in time over 2 minus 1. So if we plug 2 in for position into the position function, we get 1298. If we plug 1 into the position function, we get 1346. So s of 2 minus s of 1 over 2 minus 1 is negative 48 feet per second. The unit is in terms of velocity, so we have feet per second. Part C, find the instantaneous velocities when t equals 1 and t equals 2. Now we can use velocity function because it's asking for the specific velocity at these times. So we can plug 1 into the velocity function. If we plug 1 in for t, we get negative 32 times 1, which is negative 32. If we plug 2 in for velocity, we get negative 32 times 2, which is negative 64 feet per second. Part D, find the time required for the coin to reach the ground level. So S sub t is the final position. Okay, t is the time at any point in time, any point in the path of this object. So this is the final position. So ground level means the final position is at 0. So if we replace 0 in for s sub t, then we can figure out, if we solve for time, we can figure out how long does it take for this object, which starts at 1362, to end up at 0, which is the ground. So if we set 0, or if we set s of t equal to 0, replace s of t with 0. And if we solve for t, we can go through this algebraically. So subtract 1362, divide by -1, we get 16t squared equals 1362, divide by 16 from both sides, take the square root, we get t's plus or minus, however we know t is greater than or equal to 0, so using our calculators we get 9.226 seconds. Part D, last part, find the velocity of the coin at impact. We know that it's going to take 9.226 seconds for the object, for the coin to hit the ground. So if we plug this t value into the velocity function, then we can figure out exactly how fast this coin is moving at the point of impact. So if we plug a 9.226 into the velocity function, we get negative 295.242 feet per second. Okay. All right, 98. So here we're again using s of t that's given to us. A ball, this time the ball is being thrown from the top of 220-foot building with an initial velocity of -22. So v sub 0 is -22. And the height is, initial position is 220. So we can, from that information, we can create our specific position function, replace v sub 0 with -22, replace s sub 0 with 220. So we have our s of t position function here. It says, what's the velocity after 3 seconds? What's the velocity after falling 108 feet? So we know we have to involve velocity. So we have to work our way down to the velocity function. So again, we go through power rule. Derivative of position is velocity. So going through power rule, we get -32t. -22t becomes -22. And the constant will go to 0. So once we have our velocity function, we can find out the velocity after providing it a specific t value, time, t equals 3. So if we plug 3 in for the velocity function, we get -32 times 3 minus 22, which is -118 feet per second. So at 3 seconds after the ball is thrown, now the ball is traveling at -118 feet per second. The negative indicates that this ball has this velocity has direction, so it's moving down, so therefore -118 feet per second. Okay, what's the velocity after falling 108 feet? So this is a little bit misleading because 108 doesn't represent the height of the ball at that moment. So it's starting at 220 feet, but if it falls 108 feet, 220 minus 108 is actually 112 feet. So it's actually 112 feet above ground, even though this 108 is a little misleading. So we have to use the 112 to help us solve our problem. So it's asking, what's the velocity after falling 108 feet? In other words, what's the velocity when the ball is 112 feet above ground? So we want to find out the time that it takes for the ball to reach from 220 feet to our endpoint. In this case, is 112 feet above ground. So we can replace s of t with 112. S of t is our final position. In this case, the position that we're interested in is 112 feet above ground. So we have to just solve this algebraically. But notice that we have t squared and t involved here, so we'll most likely have to go through either factoring or quadratic formula. We bring everything over to one side, so subtract 112 from both sides. Negative 220 minus 112 is 108. Negative 16t squared minus 22t plus 108. If we factor out to -2, we can continue factoring. We get t minus 2 and 8t plus 27. If we solve for t, we get 2 and -27 over 8. We're only dealing with positive time values since the ball is being thrown starting at t equals 0, so we're only dealing with positive time. So -27 over 8 is eliminated. If we plug 2, so 2 is the only t value that's of interest for us. So now we know that it's going to take 2 seconds for the ball to reach from 220 feet to 112 feet, but it's asking for the velocity at this moment in time. So we can then plug 2 into the velocity function. Negative 32 times 2 minus 22 is negative 86 feet per second.